After these different presentations, mainly regarding 3D printing, we will put now light on another aspect, which is quality control. And therefore, we have this pitch held by David Fehrenbach.
Yeah, thank you very much. As long as the PowerPoint is loading, I have a quick question for you. Like, who of you understand what visual quality inspection is and who uses automation for doing so right now in their companies? I think I saw exactly 0 hands. 1 here, okay, that's great. Okay, I hope I can give you a bit of an overview today. Let's start directly with a use case. So this use case is in tunneling. So their complex machine is like basically digging a hole and then mounts these concrete parts, which you can see here in the picture behind me, into the tunnel wall. So they have the following issue in modern traffic tunneling. If a defect tunnel arrives, the tunnel segment arrives there, it's kind of a problem because it could lead to a stop of the machine. And as soon as the machine stops, it can cost up to $300,000 every day as long as it stands still. So our customer, which is actually also here at bauma, came to us with that issue, and we developed the system together where we installed 4 cameras inside the tunnel boring machine, which constantly films the transport of the tunnel segment to the front, and then we do different image processing tasks with the image material. So we use artificial intelligence for that, which is trained to, for example, detect cracks in the surface of the concrete element, or if the dovels or other inbuilt parts are missing or hanging away. And all this data goes into a database, and later on the machine operator gets a notification as soon as we find something, and then can do the corresponding action. So all this works in tunneling, but it also works with other concrete products as well as other materials. But basically what is always the same when we sell a project is the infrastructure where we build AI models in order to find defects. Then the dashboard, which you just saw before in the video, and then this all is installed on a Power Edge device. Like, it's basically a computer with a very strong GPU. And what is very dependent from each use case is like what kind of cameras we use, as well what is the special APIs for like communicating with the SPS or with the ERP system, and later on also the light and installation. I also would like to quickly tell you a bit about what is going on behind the scenes. So the CVC infrastructure basically is a software where you can put very modular pipelines for quality inspection. So on the one side, we can read almost every camera input which is right now on the market. On the other side, we can also communicate with all the SPS systems. And then we have infrastructure to train actually AI model. We only need like around 30 pictures per defect, so it's quite a quick task. And then we can basically already implement the first model. By using this AI, we are having a really quick setup of the system, and also we're able to adapt that to individual quality needs, which can be different from one plant to the other at the end. Or at least this is what we see in the market. And also it's possible to detect like anomalies which we haven't seen before. And it's also usable with a high variety of a product. So how are our customers profit? Yeah, obviously you can suddenly prove parts with a reasonable and standardized quality metric system. Then you have a reduction of cost, otherwise we wouldn't exist, I guess. Then you have a gapless control and documentation with image data. That's actually a big trigger, especially if it goes on and you have, for example, insurance cases later on. Then you take the employees out of the danger zones, especially in tunneling, obviously a issue, and you have the possibility to do really quick checkups. We also need strong partners for doing so. So we're quite well connected with AI research centers, but also from the concrete background. And here's another use case. The customer is also here at bauma. They have a quality inspection system for concrete stones, and together we would develop that because he was really good in finding out the height control of concrete stones, but now he also wanted to find like anomalies in it, like lifts or chippings, holes, cracks, stuff like that, and it's all done on the wet side, so without touching the actual wet concrete. The solution was development of a system which combines a 3D and a 2D sensor, and at the end it works with 1 meter per second production, so it's quite quick in response. What is interesting is you can also see here the output of a system like that, so the little colored dots are actual defects found by the AI. So if you're interested in what we're doing, we always offer a free feasibility check, which means if you come with us with some problem, we can check it, see if we find a solution, and also proof for economic efficiency and if you're able to achieve your quality goals. Later we have a proof of concept where we normally just check if the requirements also work in practice, for example, by collecting and performing image data. Then it's the actual implementation where we build up the hardware in the plant, and later on we have the rollout where the first model is used in a real plant. So if you have any questions, feel free to also pass by at our booth right over there. And there we have a small model of the first use case you just saw from tunneling. And I'm more than happy to answer your questions. Thank you very much.
Thanks a lot, David.